So this video is on descriptive statistics using R. So one of the most important things in R, or objects in R, is a data frame. And if you use Python, and there is a package called pandas, and pretty much the idea of data frame is used in pandas as a table. So if we get a good grasp on data frames here, when you go to Python, you can understand that easily also. And there have been cases where, or there are still cases where, we could connect pandas to R and vice versa. So first step, I'll show you how to create a data frame. In addition to being a flexible excuse me, data object, data frames are pretty much used in every statistical function that are predefined in R. So knowing how to create a data frame is quite important. So first I'm going to create a list. And I'm going to create another list. And we use the data frame function. And I'm going to give the name for each variable. So I'm going to give the name var underscore x for the variable x, and var underscore y for variable y. And I'm going to save that to my.df. Of course, you could use a different name if you want. You could say my underscore df or df, entirely up to you. So in the console, if I did my.df $var x, I'm going to get the variable x. Y, I'll get the variable y, and if I simply type my.df, I end up getting the table itself. So pretty much a data frame is like a table. So it's more like a matrix also, but only here you have some additional flexibility in terms of the programming environments that R itself is. So some of the common functions or descriptive statistics that we have are the mean. So I'm going to find the mean of variable x. And I could also find the standard deviation. It is simply SD. And I could find the variance I'm going to use the paste function to combine my outputs. I'll say mean is mu, standard deviation is S, and variance is V. So I have computed the standard deviation and variance for y and the mean for x. And that's what I'd end up guessing. the mean is 1, the standard deviation is looks like -1. So the mean is 1, standard deviation is 1.67, and the variance is 2.81. So we don't want to go through this process individually, in the sense if we have a data frame with 100 different variables, we don't want to find the mean, the variance for each variable. So to make things handy, we have a function called summary. So I could either do summary my df variable x, going to save that object to a variable s.x, and I'm going to print that summary. And you can see it is giving me the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. But you may say, well, even in this case, I have to find the summary statistics for the first variable, and then I have to find the summary statistics for the second variable, and so forth. Fret not, and I'll show you how to fix that in a second. So how do we access the individual elements of the summary object? It's quite straightforward. I could say print mean, and s.x is the summary object. I'd put a $, or I believe it's just 1. And it saves the value of -1. So s.x is a list, but it doesn't have a name, which is why we're not able to access it with a $sign. But the first element would be the mean, the second element would be the first quartile, the third element would be the median, the fourth element would be the third quartile, and the fifth element would be the maximum. So you can access individual elements that way. So if I want to find the summary of the entire DF or data frame, I'm simply going to say summary my.df. And you can see that the minimum, first quartile, median, mean, third quartile, and maximum for the first variable and the second variable are compiled simultaneously. So even if we had 100 variables, all 100 variables would be displayed here, and you would have a summary for each of them. One of the most commonly used data sets in R programming for educational purposes is the iris data set. So I'm going to load the iris data set. It goes back to Fisher, who did a study on this, I believe. I'm going to use Iris 3. So first step, we look at this data, and when I do data, the name of the data set, I end up getting the variable here as a promise in the environment. But I could take that and save it to a data frame. So I'm just going to create iris.df and save it to iris. Save iris3 to that data frame. And I want to quickly see what's in iris.df. One way is to simply do summary iris.df. And it looks like it simply is a vector. In other words, we just simply get the mean, median, minimum, maximum, and so forth. But I would like to know the structure of the dataset itself, because I know that Iris dataset looks different. So I'm going to do something called head of iris.df. That is going to print the first few lines of the dataset, and tail would print the last few lines, and that's what we have. So I'm going to go back to the Iris dataset instead of Iris3, and I'm going to do head iris.df. Now that is what I wanted to show you. So you have a species of iris flower, and we have the length, the width of the sepals, and length and width of petals. And I did head of iris.df, I got the first 6 lines, and tail iris.df is going to give you the last 6 lines, and we clearly can see that there are 150 rows. And we could do a summary quickly. And as I said, if we have the summary option, it is going to give the summary for every single variable that we have. Take note that the length and width for the sepals and petals are numerical, and we get the minimum, the maximum, the mean, the third quartile, the first quartile, and so forth. But the last variable here, species, is actually a categorical variable, so we can't find the mean and the max. We'd rather have the number of Setosa species, the number of versicolor species, and the number of virginica species. So it tells us there are 50 observations for Setosa, 50 for versicolor, and 50 for virginica. So now we have a data frame for the iris data, and we looked at the summary of the iris data. We have a good idea as to what the iris data is about. So just like Maxima, R has functionalities to create a bar graph, and having things as a data frame is essential in R, because most of the functions are based on a data frame. So let's go to a regular or a simple bar plot function. And so the name of the function is bar plot, and we can take iris.df and access species, because that is the categorical variable, and we can run that, and it gives us an error, and that is height must be a vector or matrix. So the reason for that is here we don't have it as a frequency distribution. Keep in mind that we need a frequency distribution in order to create a bar plot. So how do we get that frequency distribution? It's quite easy in R. So the intermediate step here is to create a frequency table. It's simply table and if I type that, I end up getting Setosa 50, Versicolor 50, Virginica 50. So now I could go back to bar plot here and do freak iris. And I get a bar graph. And you can see that since we have equal counts between the three, we simply end up having 50, 50, 50. The height of the bars are exactly the same. We can add a title. We could give an X label, Y label, we could also give a different name. So if you don't want Setosa, Versicolor, Virginica specified that way, I could specify as Setosa, Versicolor, and Virginica. So you can see that we have customized the labels for each of the bars directly. And we could specify a color. And we get a colored graph. So there are other types of bar graphs that we can create. It's sort of hard to do it with this particular data set, so we can go for a different data set in R. I believe it comes in the base package. Yes. So let us load another package here. Cars is also a default package in the base package or base system of R. So I'm going to load cars, and I'm going to save it to a data frame named cars.df. And we want to see what's in the dataset cars, so head, cars, there is speed and distance, tail, cars, speed, distance. It doesn't have any categorical variables that I'm looking for. Let's see, I could think of a different data set. There is another one, empty cars. So getting an initial glimpse into the dataset is very, very important, and the head and tail functions are quite easy to achieve, make it quite easy to achieve that. So let's see what we have in the cars, or the empty cars data. So it seems like we have different vehicles, and we have miles per gallon, the number of cylinders, horsepower, weight, the number of gears, and so forth. And we did tail cars.df. It's going to give the last 6 vehicles that we have, and as always we could simply do summary of cars.df, and we end up getting all of those. So those are the variables that we have in the cars.df dataset. Now we can sort of create a stacked graph. For instance, so we have the number of gears here, and not good with cars. Well, we could compare it to cylinders. So let's just do table of gear or cars.df $gear. So there are 15 of them with 3 gears, 12 of them with 4 gears, 5 of them with 5 gears. But if I take table cars.df, so I have 11 of them with 4 cylinders, 7 of them with 6 cylinders, 14 of them with 8 cylinders. But what if I want to find an association between the two? In other words, I would like to form what is called a cross table. So we could simply do table so that is the distribution we have. So the number of vehicles with 3 gears and 4 cylinders is 1. The number of vehicles with 4 gears, 6 cylinders is 4. The number of vehicles with 5 gears and 8 cylinders is 2, and so forth. So I'm going to create a table . and I'm going to make a bar plot. So I'm going to use the car.table that we just created. So that's what we end up getting. So by default, it automatically populates into a stacked graph because we want to know the number of cars with 4 cylinders and has 3 gears would be that portion right there, and so forth. We want to make this colorful, so what we can do is use the color argument and pick colors: tomato, steel blue, turquoise. So we have 3 different levels for corresponding to the 3 different gears that we have. So the y-axis here happens to be the cylinders. So I'm going to change the label to cylinders, and it's good to have a legend because we don't know which color corresponds to which. So we have legend, and legend would simply be the row names of our table. So if we go back and look at our table, so the row names are 3, 4 and 5. We clearly know the cylinders here: cylinder 4, 6 cylinder, 8 cylinder, but we do not know corresponding gear. So if we pick the row names function would pick the row names of the table we just created. So if we do that, we get the legend over there. So there are ways to move this legend to the top or to the side. If you look at the legend function, that gives you the exact position where you can put the legend. But since this is within bar plot, we may have to specify or annotate the plot in a different way. So I believe it's inside equals true. Let's try inside equals false. That's not it. Let's scroll through and find this. I don't think we could pass a separate function, so let me try this. Legend might do it. It did not. Let's see if it can do it by default. Let's just say true and see what happens. It's still putting it inside. So there are ways to adjust the parameters so that we can move the legend outside of the graph. And I don't want to get into all the details of that because there are way too many parameters that we can toy around with. So I'm just going to leave it as row names of car.table. Of course, you could use legend equals true. That would work also. So that's how we create a stat bar graph, and we could also create what we call a grouped bar graph. So just going to copy paste that, and instead of stacking everything together, we could simply state beside equals true, and you can simply see now the legend is in a nice place. So you can see the 3 gear 4 and 5 for the 4-cylinder case, the 3, 4, 5 gears for the 6-cylinder case, and the 3, 4, 5 case for the 8-cylinder case, and so forth. Now there is also another option where we could have entire thing and specify horizontal equals false as the default setting, but if I change that to horizontal equals true, now the bars are in a horizontal manner. So you can either do a grouped bar plot, a stacked bar plot, or you can simply do a bar plot in